This is terrifying. Dark matter may destroy us in the upcoming future. A massive gigantic void has been observed in the universe. The universe contains a gigantic void that is orders of magnitude larger than anything else of its kind. The discovery took astronomers by complete and utter surprise. The black hole has a diameter that is close to 1 billion light-years. A black hole is a small sphere containing an extremely dense concentration of matter. This object does not fit that description. Rather, this one is almost entirely devoid of stars, gas, and other regular matter, and it's also oddly devoid of the enigmatic dark matter that permeates the entirety of the universe. Hey viewers, welcome back to the Future Space. In today's video, we are going to observe a massive mysterious hole in the universe. Have you heard about Gargantua? If yes, then tell us what you know about that, because today's video is for you if you love black holes. Stay tuned with us till the end of this video so you don't miss out on any of this information. But before we proceed, don't forget to subscribe to our channel and click on the bell symbol so that you don't miss out on any of our wonderful videos in the future. And let's get started. There have been discoveries of other space voids in the past, but nothing on this scale. Astronomers are at a loss to explain why the hole is present. According to researcher Lawrence Rudnick of the University of Minnesota, not only has no one ever found a void this big, but we never even expected to find one this size. In addition to Rudnick, his colleague Lilia R. Williams was taken aback by this discovery. According to Williams, who is also affiliated with the University of Minnesota, what we found is not normal, based on either observational studies or on computer simulations of the large-scale evolution of the universe. The discovery will be discussed in greater depth in the journal Astrophysical Journal. Stars, gas, and dust are all examples of the observable matter in the universe. However, the vast majority of the universe's matter is invisible. Due to the fact that scientists are able to measure the gravitational effects of so-called dark matter, they are aware that something is present. There are voids, but in most cases, they are on a moderately small scale. Examining observations obtained with a very large array radio telescope, which is supported by the National Science Foundation, led to the discovery of the enormous hole. According to Rudnick, there is a remarkable drop in the number of galaxies in the portion of the sky that is contained within the constellation Eridanus. Because of its prominence in a map of the cosmic microwave background radiation produced by NASA's Wilkinson Microwave Anisotropy Probe satellite, the region had been referred to in the past as the WMAP cold spot. The cosmic microwave background is an imprint of radiation that was left over from the Big Bang, which is theorized to have been the beginning of the universe. Although our surprising results require independent confirmation, the slightly colder temperature of the CMB in this region appears to be caused by a huge hole devoid of nearly all matter, approximately 6 to 10 billion light-years from Earth, Rudnick said. Although our surprising results need independent confirmation, the slightly colder temperature of the CMB in this region appears to be caused by a hole in the fabric of spacetime. According to the explanation provided by the researchers, photons of the CMB pick up a negligible amount of energy as they travel through normal regions of space that contain matter. However, when the CMB travels through a void, the photons lose some of their energy, which results in the CMB from that region of the sky appearing to have a lower temperature. Let's understand it deeply. There is a monstrous beast that lurks at the very beginning of the universe, and its mass is 10 billion times that of our Sun. And one of the first jobs that the James Webb Space Telescope will have is to help astronomers determine whether or not it is what it appears to be, a supermassive black hole, one of a handful of the largest black holes ever found, dating back to the earliest moments of star formation. This will be accomplished by penetrating the veil of incredible distance and time that has surrounded it. Jinyi Yang, an astronomer who is currently serving as the Peter Strittmatter Fellow at the Steward Observatory at the University of Arizona, is in charge of the search, which is a component of the first cycle of observations performed by JWST. Her team will be one of the first to use the new instruments that will be available on the JWST in order to observe the formation of a quasar, which is the ultra-bright core of a galactic nucleus that has a supermassive black hole at its center during an epoch in which stars and galaxies were only just beginning to form. What's new? As JWST has started to release its first images to the public, this is one of the general observer's targets for Cycle 1 of the mission. The new Space Telescope will dedicate 6,000 hours of its time over the course of the next year to projects that have been chosen from proposals submitted by physicists and astronomers from all over the world. A total of 286 projects were chosen from more than 1,000 proposals submitted by 44 countries. The majority of these projects are relatively brief, just like this proposal. The total time that Webb will spend on these measurements is less than 6 hours, but the gains that astronomers make from them will be unlike anything they have ever seen before. In an interview with Inverse, Yang noted that the sensitivity and resolution of the near-infrared spectrograph on the Webb telescope means that astronomers will be able to see what we have never seen. The ability to get high-resolution data from spectra in the mid-infrared wavelength, range from 30 to 50 micrometers, will enable astronomers to catch a glimpse of a monster black hole from the very beginning of the formation of stars, galaxies. Why it matters. J00380653, the quasar that Webb will focus on in this research, is one of the very oldest that we are aware of. Because of the inflation that occurred in the universe, the infrared waves that it emits date back to the first 800 million years of the cosmos' existence, which means that they have traveled for a total of 13 billion years to get to us. Due to the immense distance between them, even the most sophisticated instruments were unable to do much more than verify the object's existence. In point of fact, the first quasars from this early in the formation of stars, galaxies, and black holes were only found a little bit more than a decade ago. Yang attributes the direction of her career to the discovery of these quasars. The quasar is moving away from Earth because it is so old. As a result, it appears in such a high redshift that it can only be observed at high resolution with instruments that can cover the mid-infrared spectrum. The NIRSPEC instrument on Webb will be able to survey a very small portion of the sky in order to determine the size of the supermassive black hole that resides within the quasar. At this point in time, the mass of the black hole is something that astronomers can only estimate in a very general sense. If we had a measurement that was significantly more accurate, it would be much easier to understand how black holes first started to form in the very early stages of the universe. If the JWST is able to verify that this quasar really is as massive as it appears, then it would indicate that the first black holes were particularly massive or grew at a much faster rate than their contemporary counterparts do. Because high redshift quasars like this are one so bright and so far away, observers of them and their spectra provide direct information about the state of the intergalactic medium as galaxies formed. The intergalactic medium is the extremely diffuse plasma that isn't gathered into galaxies. Dr. Yang also notes that because of this, observations of high redshift quasars like this one provide direct information about the state of the intergalactic medium. During the period of reionization, the light from quasars sheds light on the process by which the first galaxies came into existence. So, what's next? As the program begins to work through its first observation objectives, Go projects such as this one are going to be using a little bit more than half of the time that the JWST has available over the next year. But for the time being, she adds, it's a little nervous to wait for the data but very exciting. Right now, this is one of 29 small projects focusing on supermassive black holes and other active galactic nuclei. Dr. Yang notes that these projects are going to start a whole new generation in astronomy. And that's it for today, guys. We sincerely hope you enjoyed the video. If so, please click on the like button and share it with your friends and family. If you have any questions or comments, please share them with us in the comment space below. Also, don't forget to subscribe to our YouTube channel to see even more of our incredible videos. You can also check out our other videos that have been specially selected for you. We'll catch up in the next video. Thank you so much for watching.